Frontier models are overused. We throw all kinds of trivial problems at them all the time. We should not do that. It's a waste of compute, it's a waste of money, it's a waste of tokens, it's a waste of water.
AI Native DevCon is back.
The leading event for engineers and organizations moving agentic development into production.
Join us on June 1st and 2nd at the Barbican in central London.
For 2 full days of workshops, fascinating talks, and great company.
You'll hear from some amazing speakers, such as Ryan Lopopolo from OpenAI, Dana Lawson, CTO at Netlify, Justin Cormack, the ex-CTO of Docker, and Birgitta Beckler from ThoughtWorks.
They'll join speakers from Anthropic, NVIDIA, GitHub, Cisco, Meta, Adobe, Mozilla, and many more.
This is a practitioner-led community event and would love to have you join us.
Head over to ainativedevcon.io to grab your ticket.
We'll see you there.
Good evening. So yeah, as I did just briefly introduce myself, I'm Shaun Smith. I work on MCP agents and various open source projects and initiatives at Hugging Face. A couple of things I do there is I look after our MCP server, make sure that that's healthy and running well. I help maintain our skills projects. And I also was a very, very early adopter of MCP, and I'm currently an MCP maintainer and community moderator. I spend most of my time at the moment working on transports. So if anyone wants to talk MCP transports during the networking, that's a reasonable topic. I'm hoping that most people here are familiar with Hugging Face in one way or another. There's some few nods. Yep, so we've got a huge community, and we host models, we host research papers and data sets to help people use models. We also have thousands and thousands of AI applications hosted on our Spaces platform. So people can develop and build and train models, and then they can show demos or host those things on our zero GPU services. And it's all very, very good fun. So I mentioned I was an MCP maintainer and a fairly early adopter. And so for this talk, what I was going to do was sort of go through some of the stuff we've been doing with skills, but really kind of start off with kind of thinking back to where we started with tool calling and how we've ended up with skills and how we've then ended up with some of these more complex evaluation pipelines and tools. And so if we kind of go back to when MCP was first launched, it was all actually really, really quite straightforward. If you recall, if you were playing with this stuff then, you would connect an MCP server to your LLM. You would normally have to configure that with a JSON file, and you would write a prompt, and you would see the tool call, and you would kind of clap and say, well, that's brilliant. I've connected one thing to another. Things that we didn't really have then were, we didn't really have sort of particularly good harnesses. We had the Claude desktop app, and we had a few other kind of fairly custom applications that we could play with, but nothing that was kind of really nice to use or easy to configure. We didn't have agents.md files. I mean, that feels quite straightforward, doesn't it? It's such a simple thing as, a text file which helps drive our agent's behavior, but we hadn't kind of agreed that that was actually a reasonable and a good thing to do and share between our tools. And the other thing that kind of changed was we didn't have long-running tool loops, right? So, it used to be the case you could kind of prompt it to chain 2 or 3 tool calls together, but actually these kind of loops that from a single prompt will run for an hour or 2 hours and sort of chain together 50 or 60 tool calls as it moves towards a task, just weren't really a thing. Okay, so what happened and what changed? So the kind of magic, if you like, is that labs knowing that, particularly for coding tasks, they could place models in environments and conduct reinforcement learning on them. And actually it's fairly, what you actually do is relatively straightforward conceptually, which is you place your model in a harness in an environment, and you write a reward function and you give it a task. And typically the reward functions are fairly deterministic, and you may be able to judge the task on a scale of sort of 0 to 10 or whatsoever. And then you generate that data and you you then train the model to kind of reward itself and keep driving the loop without needing lots and lots of intervention and steering. Something that we've kind of added on the hub is a bit small. I was going to do a zoom in for this. But something that we've also added on the hub is agent environments to actually help set up these kind of training environments so that you can have a go at doing your own reinforcement learning. It's quite good fun if you know, the sort of the typical starting point for this would be if you want to train a model to play a game, or if you want to train a model to do a couple of other things. It's fairly straightforward to write the reward functions for that and then place that in an environment and train a model to do so. The other kind of quite important thing that's happened here, and we'll look at this in just a second, is how free of the harnesses models have become. And what I mean by that is that harnesses can now be very, very simple to get jobs done. And the example there is Mini SWE agent, which is a single 100-line Python function effectively that can score 76. I think actually the latest numbers are 78.6% on SWE-bench. So you have all of these very, very complex harnesses, but actually a single 100-line program can get close to the state-of-the-art performance straight away. And so this is something that we've kind of seen evolve over the last year, is actually as our models become more and more capable, inversely our harnesses become an awful lot simpler. And the kind of changes that we've seen is general purpose harnesses now are given direct shell access. I've put an asterisk there because actually sometimes we'll give them secure shell access or through an environment like Just Bash or something which is more secure. But typically we give our models a way of kind of navigating freeform with the outside world. We have much fewer hacks and tricks to keep models from doing what we want to do. We might occasionally inject something into the message loop, but those kind of techniques are kind of a lot simpler. If you were kind of developing LLM applications about a year or so ago, you would normally be looking through various libraries, and you'd be looking at the API surface, and you'd be looking at the model support. You'd be kind of figuring out, how can I build a workflow out of these steps and considering it. If you're building LLM applications now, you do something completely different, which is you take any tool loop that you can easily get hold of, and you can basically just start using it. So it's, again, a lot of this stuff, as I say, there's models become more and more capable of doing this stuff. We can have simpler and simpler harnesses. Building these applications are simpler. The kind of workflows that we may have previously deterministically coded have kind of been taken over by models simply being strong enough to follow instructions, or by models generating their own scripts and code so that they can achieve a goal. Okay, so these are the kind of things we see. So this is also why skills are interesting, because it's quite easy to look at skills and almost dismiss them as being, well, it's just a bunch of markdown files. I mean, how simple can that be? But there's something else that's actually going on here, right? Which is that we taught models to be self-directing. We give them a task, we give them the capability to navigate, so they can look at content and then they can ingest content. And critically, having ingested content, they can then act upon what they've just ingested. Okay, so this effectively means that models can do very, very complex tasks, and we can configure and set them up in very, very, very simple ways. So given that, this is just an example that I like. One of the things that we like doing with our MCP server and with our spaces is we have, as I mentioned, thousands of image generation models, OCR style models, audio generation, pretty much any custom models, privacy filters most recently. So pretty much any custom model is available through either an MCP API or a Gradio API on our platform. And because models have just got this little bit of extra capability, the way that used to work for us was that we would, in the MCP server, say, right, I want to use this particular model to generate an image, or I want to use this particular model to conduct some OCR. But what we can now do is dynamically give models access to, literally thousands of capabilities with a 45 token tool footprint. Because the model can say, we can ask, I would like to rotate the image. I would like to move between two frames. I would like to generate an audio book from this web page. And because the model is capable of calling a tool very simply, which in this case is our dynamic spaces tool, we then effectively have a gateway, which means that we can access literally hundreds and thousands of models through a very, very small token footprint. Okay, so it lets us mix and match and, just have not just capabilities to read skill files, but capabilities to actually conduct inference against pretty much any model and discover those things at runtime rather than having to set these things up earlier. Okay, so this is the kind of the kind of power that RL and these things have opened up for us. And of course, that's why this has opened up skills. This is why skills are important, because the ability for the model to navigate, and by that I mean, list files or grep some skills in a very, very token-dense format, right? So it doesn't matter that we're using shell commands. The point is that it's token-dense. A single token will list some files. 3 or 4 tokens will conduct a search and get the results. So it's an extremely efficient way for a model to bring context into itself for further action. And the other kind of, the quite interesting thing here is that we can seed models, it's not just documentation, but we can also provide ready-made or customizable scripts so that we can do some fairly big deterministic actions or modify those actions fairly easily to effectively massively extend the capabilities that we have. So when one of the kind of things that particularly interests us is training and fine-tuning and deploying models, right? So the general process is that you have to identify a data set that you want to maybe fine-tune a model on. So I'm hoping most people are familiar with fine-tuning. So the idea is that we would take an existing model, we would then sort of get some data which told us how we wanted the model to behave in future turns. So we might, for example, a silly example would be a talk like a pirate set of conversation pairs. And then we take the model and then we run the model through a number of loops where we say this is what we want it to look like. And then ultimately a new model comes out at the end. You can download it and you can run it in a tool like llama.cpp or LM Studio or so on and so forth. And this, I would say up until we kind of had these skills, this wasn't something that was necessarily casually accessible. Okay, so what the skills enabled us to do was to, and again, using straightforward off-the-shelf tools like Claude Code, we can say add this skill and it'll then guide you through the process of constructing a data set, building do you want to synthesize your own data or do you want to use someone else's data? What hardware do you need to actually do this? In fact, you might be surprised. Often it's sort of $2 or $3 worth of compute to do some very, very basic fine tunes. But it will run the training scripts. It will set up monitoring for you, so you can watch the loss curves. It will turn it into a GGUF format so that you can run it locally. And so, skills have kind of made this a huge amount more accessible for people to actually start to think, right, well, even in fairly simple cases, it's become very accessible to build and tune and fine-tune a local model. We've then also got some slightly more sophisticated needs. So we were just talking about kernel writing. I'm certainly not an expert, but for the people that are, again, we've got a kernels library. Kernels is now something that we host on the hub, and the idea behind hosting kernels on our Hugging Face hub like this is because there is still, and as we saw from the previous talk, there are still optimizations that people can make and have for particular hardware classes, for particular algorithms. And so kernel building and distribution is something that we can do. And also the nice thing about that is that certainly for kernels, we can actually have a fairly deterministic outcome as to did it work and was it faster or more efficient than the previous one before. So again, quite a useful thing for us. It was there. Just, I've put a note on the slide there because I did want to mention this, is that obviously we maintain a number of quite important libraries like kernels, like transformers, like diffusers, which people use to build and test and train and deploy their own models. And so what we've generally found is that we're finding it more valuable for people to, for example, download kernels or transformers and then add the skills through their own CLI. So you can say transformers add skill to the local directory rather than having some other third-party installer. It feels a lot more comfortable to package it that way. So when it kind of comes to does this stuff actually work? Actually, I'm just going to pop on a slide in a moment. Was a tool that we built and we're still maintaining. We like it quite a lot. It's a tool called Upskill, so that we could do a number of things actually. So we can look at existing traces or existing skills and generate new skills. We can evaluate whether or not the skill is actually useful, or we can compare the performance of one skill against another skill for a particular task. And again, we kind of did this with the kernels, we can use large models to generate instructions that we can then use with smaller models so that we can get similar performance from smaller models. So it's almost like a very kind of crude form of distillation, if you like, where we have a big model tutor smaller models, which may be faster, cheaper, or a better fit for any number of reasons. And you know, the kind of things that we see there, I didn't include this in the presentation, but you know, this is a kind of example. One of the things that building the MCP server and developing these skills is important for us is making sure that what we're building is applicable and working across a wide range of open weight and proprietary frontier models. And sometimes we have to make trade-offs where we may see a drop in performance in one model, but it improves other models. So it's always a slightly shifting thing. But again, in this example, I think this was quite, a fairly outrageous one where we've got two versions of the skill, and it generally, the improved version of the skill generally improves performance quite a lot, except for Grok 4, which for some reason goes through the floor. But who knows why? It's a very strange model. And so the other nice thing that we can do with Upskill is, you know, when we first developed this, we were doing quite a lot of local development, and all of the kind of tropes and memes about agents running wild came true as we were developing Upskill and kind of running tasks like write queue to kernels or finish off a good pull request, as models were sort of running over each other and stealing each other's results and generally misbehaving. But so what Upskill does now, in fact, I'll be brave enough to do a live demo. But again, it's, you know, a typical Upskill run might be something where we write, integrate, and benchmark an optimized CUDA kernel. We can see that it does improve performance. So based on the automated tests it produces, it improves performance. But obviously at the expense of rather more tokens. Okay, but these are the kind of things that we like to know and we like to kind of calculate. So I'm just going to, I think that will run. So this Upskill, I've got I've taken our normal kernel skill. It's now generating some test cases. We're not going to see this to completion, but I did just kind of want to just kind of show how it integrated with a couple of our other components. But you know, we can give it a skill file. We can tell it which models we want to use for generation, for evaluation, for testing, or for benchmarking. And we'll see if this then submits any jobs. So I cancelled some jobs earlier. We'll let that run. And of course, the other nice thing is that we've been spending quite a lot of time working to collect and make it easy to publish agent traces. So the idea being that we can, given an agent run, it's easy for you from your harness, whether you're using, in this case, fast agent, in other cases it could be Pi or Codex or Claude. It makes it easy to publish and share those traces so that you can then have a really good look at what actually happened and where the tool calls were and where there were any errors and that kind of stuff. So after you've run Upskill, I'm not going to obviously get those jobs running. Oh no, there it goes. So yeah, so it's now created a sandbox for each of those particular evals. They should appear as scheduling in a second. I'm determined to wait for it now, so I'll try and crack some jokes to keep you entertained. Yeah, there it goes. Look at that. Sorry?
For an hour.
Oh yeah, that one's doing some analysis on pull requests for transformers. So yeah, you can see they're all nicely labeled. Our jobs are now all running. So each has got a very isolated sandbox. It's not going to mess up your own local computer. And of course, in cases where you have things like a kernel performance test, you could actually deploy it on some sort of decent hardware. You know, this is running on CPU basic at the moment, but we could run that on some fairly serious hardware if we needed. So the nice thing about skills is, you know, it kind of almost, you know, when we're using it for tutoring and selecting best price performance, it kind of gives us something between the hassle of fine-tuning something. It's a lot simpler than that, but also something which gives us a huge amount of extra boost so that we can use better fit models for a particular task. The other kind of thing, just an area where I think we're going to start to see some real progress very soon. So I'd say this is, some of the stuff I'm talking about is probably a slight work in progress, but I think this is something which is quite important for us, is we're kind of increasingly seeing that people like interacting with things in fairly natural language. And we haven't got a huge API surface, but it's a big enough API surface that it can be sort of somewhat difficult to navigate and manage otherwise. And so we want to give people sort of, you know, fairly good and free access to that. And of course, models are very, very good at generating codes and scripts. I'm mentioning the tool builder there, which is actually another skill that we have, which will navigate our open API spec and build shell scripts or Python scripts that you can compose together. But the other thing that we started doing is some code generation. So we've got a general query tool. And the reason I kind of bring this up is because one of the important things about this query tool is that it generates code and then it doesn't post-process the result. It gives you the answer straight away. And we're using, in this case at the moment, we're using GPT-OSS 120B, which is to be honest, it's a reasonably big model, but it's very, very fast, right? So one of the things that, you know, we're particularly keen to do is to reduce latency as much as possible and to use the right model for the job. But again, you can, so what proportion of trending models have a number in their name? Okay, that's a query you may not ask very often, but it's not an unreasonable query. And again, you can see how quickly that code generates and actually returns an answer. Now, of course, you know, we can, I think, how many followers does the NVIDIA organization have? So again, you can kind of get this extremely snappy performance, and we expose this as an MCP tool at the moment. There's some further tuning to do, but given a kind of set of traces, given a set of inputs and what we then know are good outputs, we can start to think, right, well, actually, we can start to evaluate what good looks like over a fairly large set of data. And we can then start to think about having an even smaller model, an even faster model, and a better way of actually doing those things together. And we can extend that even further because, you know, something that, again, we're starting to see. I'm not entirely sure how this is going to fully work for us yet, but the idea that we can actually generate UI on the fly, right? So a model which knows how to generate UX components to answer certain questions, show proportions, show particular information, starts to become a lot more feasible, right? Because, you know, if we're able to customize and train and specialize models for these particular tasks, then we're in a position where we can, you know, they can be cost effective and fast enough for this to work well. So again, you know, afterwards I'm more than happy to talk about this because I've done an awful lot. Some we haven't covered here is MCP tool description evaluation, which I know was kind of like a big thing a few months back. And certainly we've looked at, and we're continuing to look at how we can avoid confusion in the model when it's given multiple options. But ultimately, the great thing is that we're now in a position where models can train other models, right? Models can use other models sensibly, they can train other models sensibly. We've now got self-improvement, it's here if you want it. owning and usefully customizing your own models is completely accessible. Try it, right? If you haven't already tried it, give it a go. You might have to copy and paste a few error messages in and have the model sort it out. You may have to, but you will get it working a lot more quickly than you think. You can train a model to recognize your pets a lot more quickly than you think. This stuff is very, very accessible. Frontier models are overused, right? The price performance of big models like Opus or GPT-5 is not as expensive. We throw all kinds of trivial problems at them all the time. We should not do that. It's a waste of compute, it's a waste of money, it's a waste of tokens. It's a waste of water. It's something that we kind of need to start getting used to, because we've got techniques and very, very simple tools that get us to exactly where we need to be with price performance. Open weight models are yours. You can adjust them, you can run them, you can do as you need with them. You're not beholden to other people making decisions arbitrarily on what is allowed on an API or anything else, right? You take ownership of this stuff. And finally, inference and execution is blending, as I kind of mentioned with the harnesses. We've kind of seen complex harnesses start to collapse towards being model enablers, and as we kind of see more advanced APIs like the responses API, or you do more local running, actually the difference between inference and execution environments is starting to blend, right? They're starting to become one and the same thing. So anyway, I'm around afterwards if anyone wants to talk about any of these topics. Hope that was useful in some way, and thank you very much.
Awesome, thank you very much, Shaun. Any questions? Oh, I thought that was a question then.
Great talk, sir. Thanks very much. I'm curious, since you're so well plugged into this space, one of the areas of self-improvement that comes up a lot of times is low-resource programming languages, things which are less popular. I'm curious if any of that's crossed your radar, where you've seen people put this to use on an ecosystem that isn't as big as Python or JavaScript and getting good results.
I can't think of anything directly at the moment, but I definitely agree that is a very ripe area where, I know that people have certainly done quite a lot of experiments of fine-tuning on particular code bases, and they generally tend to find it's worth it when they do it, but it's a maintenance that's probably not got the payback for small teams. But yeah, I think it's something that something that's ripe for exploitation.
Fair enough. Thanks, sir.
You again.
Thanks, Shaun. Great talk, packed with so much information. I don't know where to start, but I think you pointed out to a lot of things that show that when compared to 12 to 18 months, which is one of your slides, we didn't have all of these tools. And now, let's say 18 months from now, if you had to give the same talk, of course, that'll be a different discussion. But where do you see things going? Like, we've already progressed so much, like the developer tooling space has become so powerful. Where do you think, and also you pointed out something else, is where the harnesses and tools are getting lighter, and it's getting factored into the models, right? I was talking to Simon about this earlier. So where do you see things happening? Like, are developers going to be doing just pressing buttons and orchestrating and not really doing the fun stuff we're doing?
Maybe not. I think this might be a slightly cynical take. I think over the next 12 to 18 months, what we really need to see is real usage and deployment of these models to solve problems that aren't deploying and using models, right? So a huge amount of the explosion of software we have at the moment is all based around, literally what we just spoke about, which is, can I do inference? Can I write a tool? Can I do all of these things? And we kind of keep on extracting this training data out of the models and then sort of going, it's fantastic. I think what we're going to, certainly what we should start seeing over the next 12 to 18 months is more of a focus on deploying these for use cases, deploying models, deploying these solutions for use cases which are more generally useful than building the tools to build the tools, if you know what I mean. Yeah, so it's kind of like, we're very good at building the picks and the shovels, and it's we need to
Use them.
We need to start using them, and I think we've got to a capability level with current models that we there shouldn't be anything which holds us back. So I think I would certainly hope in 12 to 18 months' time, we're looking at clever business and societal application of some of these technologies. I don't think we're getting the full value from. I think there's a lot of potential and unrealized value that I look forward to us concentrating on getting.
Hi, I'm Darpan, and thank you so much for your talk. So one use case that I'm solving right now is where I'm processing a large amount of text and video, and I'm using frontier models. And I saw somewhere that you can use like Olama, very easy one, and do a little bit of training. And I was thinking about like how much it will cost and how long it is going to take. And basically, I got the answer that you can do it for 10 minutes, like a very small one. So the two parts of these questions. One is that I did not go into this because I was not sure what kind of results I'm going to get, or how am I even going to evaluate whether my results are really good. So evals are probably like LLM as a judge or something else would be an answer. So that is what I want to know. How would you compare these kind of results? And second one is that if I have a use case like this, so I always wonder that, let's say a new model came up and they will have much higher capability. Yeah. So if I'm already like training my own open source model, and it will take some time to catch up with that, and I might have to change my training of that. So in a case like that, how do you think about training your, basically like fine tuning your own model versus just going with the frontier in that case?
So, I mean, I would probably kind of collapse the question almost into a cost-benefit question, right? Which is that, I think it's fairly straightforward to assert that at a particular volume, the cost of using a frontier model is, for the performance you get, is going to outweigh the effort and money that you may need to spend to do some fine-tuning. How exactly you quantify that, I think, comes down to a lot of whether you're doing it for personal fun, whether it's whether you've got 10 million data samples, whether you've got 500 data samples. So I think there's a lot of questions to answer there, because obviously the more scale you have, the more that trade-off window comes towards that a certain level of fine-tuning or self-hosting or doing your own evaluations makes sense. What I would argue, though, is certainly that where the volume side of the equation is pushing you towards higher volume is going to mean the more volume you do, the more it's going to be worth customizing and fine-tuning. But the other side of the equation is also getting closer, which is it is becoming a lot simpler to do that, and running evaluations and so on. So it's becoming cheaper to do it. So I think, and to be honest, I think for a lot of cases, we're probably not at that crossover point. I think you would probably need to sit down with a spreadsheet or Claude code or something and kind of figure it out. But I think, again, I would say if you've got something that's working for your use case, and it's an important use case for you, then I certainly think that open weight models that you could potentially host yourself, even if you're not hosting it yourself, would be something I would want to keep hold of. So I think there's other risks that you mitigate by taking some ownership of the infrastructure.
Awesome. We don't have any more time for questions, but please give it up for Shaun Smith.